All right, ladies and gentlemen, 9.6 at the top. We're just going to take a few notes. Again, this deals with cylinders. And last lesson, we were given a surface area. We had to maximize the volume. This time, we're going to be given a volume. We need to minimize the surface area. So you're given a capacity that needs to be packed in a can. And you need to use the least amount of aluminum material possible. That's basically what it is. Okay?
The maximum area we can use.
So this lesson, 9.6, the word minimize is in the title, not maximize.
Yeah, but maximize, you could use any amount as possible.
No, when we were maximizing, we were given a set amount of material to use, and we had to make the biggest container possible. We learned it wasn't tall and skinny, it wasn't short and fat, it was somewhere in between. Okay, we're going to learn the exact same thing today. We're going to use those concepts, and now we're told the volume that needs to go into this can. We need to use the least amount of aluminum. So are we going to use a tall, skinny can?
Yes.
No. Are we going to use a short, fat can?
No.
No. Are we going to use a can where the height is 2R? Yeah. Okay.
Didn't we already do this, minimizing surface area?
We did it with prisms. We did it with a cube.
Oh,
Yeah, so now we're doing it with a cylinder.
Yeah.
Okay, here we go. Notes at the top. For a cylinder with a given volume, so like I said, this time we're going to be given the volume. For a given volume, a radius and height exist that produce the minimum surface area. That produce the minimum surface area. So if you're given a volume, you can find the radius and height that will minimize the surface area. Okay? The minimum surface area for the given volume occurs when H equals 2R. These dimensions, H and R, these dimensions can be found by solving the formula V, because we're given the volume, so we're going to use the volume formula. V equals 2 pi R cubed. This is the volume of a cylinder for R, period. Then use R to solve for H. Please ask questions about that if you have any right now. Yes?
Okay. So, the only difference...
The only difference between yesterday's lesson and this lesson is the formula that you use. Because in last lesson you were given the surface area. This time you are given the volume.
So it's the same, but we still use R for H?
The maximum volume and minimum surface area of any cylinder will still be based on H equals 2R. So this cylinder with the max volume and the most efficient use of material is that guy right there. Okay, here's R and H equals 2R. Any other questions? Jacob?
I was kind of falling behind already. Kind of don't understand anything you just said.
Okay, if you have a specific question, you can think about it and ask it. Olivia?
How come the two formulas are the same even though you kind of figure out what the volume is?
Because the last lesson we weren't given the volume, we were given surface area. So then we had to use the surface area formula.
Now we're using a volume.
So so much to take in.
Okay, that makes sense.
Well, we have to memorize.
Do you even know all the formulas?
No.
No, you will be given the formulas on your test and on your exam.
Oh, we have
Okay.
them with our with the orders.
No, you will not know what they are for. You'll have to know which one is which. Yeah, you'll have to know which one relates to a
So
cone,
just
which
like
one
this?
relates to a cylinder, just like the sheet I gave you earlier.
So
Okay.
I
Easy
need that.
to just
So here we go. Example.
Whichever one works.
Paying attention, guys. We've got a few more minutes here, and then you can crush out your practice problems. Minimize the surface area of a cylinder. So, determine the least amount of aluminum required to construct a cylindrical can with 1 liter capacity to the nearest square centimeter. Okay. There's a couple things going on here. We know the basics of what we're going to do. We're going to use the notes that we just took. But what's a little bit tricky about this thing right here? What did it give you the capacity as?
Well, a liter.
Liters. It didn't give you it in cubic centimeters. So the first thing that we need to do here
Switch it to cubic centimeters.
is to convert to cubic centimeters. So convert 1 liter to cubic centimeters. Well, we've already learned that 1 milliliter equals 1 cubic centimeter. How many milliliters are in 1 liter? 1,000. So 1,000 milliliters is going to equal how many cubic centimeters? 1,000. All right, so here's the volume that we're working with. 1,000 cubic centimeters. So here we go. We're going to use our formula, and I haven't really derived where that formula actually came from. Maybe I'll do that off to the side 1 second. So here's our formula that we said we're going to use. We're going to use 2 pi r cubed. Okay. Now, since you have some space to the right, okay, do this just on the right. We're going to say derive formula for minimizing surface area when given volume. So in there, basically what I'm going to do is just take the volume formula of a cylinder, and this is any old cylinder, okay? Of any old cylinder, the volume formula is the area of the base times height, okay? That will get you the volume of any cylinder. Now, we are looking for a specific cylinder. We're looking for the cylinder that will maximize volume. And we determined that that happens when H is 2R. So all we can do, just like last lesson, wherever we see an H, we're going to sub in 2 times R. Now we can look at what we have and rearrange things. This is all just multiplication. We have pi times R times 2 times R.
Why do we switch out H?
Okay.
never mind.
So here we put our number first, typically 2 pi, and how many factors of R do we have? We have 3 factors of R. There's 2 here and 1 there. So
Ooh.
this volume formula is special for minimizing surface area when given a volume. Okay, so this is the volume that will give you the max volume. Yeah?
So it's special for?
So this is special for a cylinder that has a height of 2R. Okay?
Cubes are squared.
This is cubed because there's 3 factors of R. Right? R squared times R.
Minimize.
No, it's for any.
For any,
Okay?
Any
Would it be
cylinder.
four?
This is
only
any
when you're trying to
cylinder.
minimize surface area.
This is a special cylinder where the height is 2 times the radius. Okay? This one is special. This is any cylinder. So if you get a question on a test that says get the volume of this particular cylinder that's like drawn for you, you use this one. Okay, if you have a question about maximizing volume or minimizing surface area, then you're talking about this one. Okay?
You
Yeah.
just said anyone that you're maximizing.
Okay, so let's use our formula and figure this thing out. All we figured out that the volume we are given is 1,000, so we can sub that in for our volume. And we're going to find out what the radius is that goes with that. So, using algebra, using bed mass in reverse, we're going to strip things away from our...
Formula.
So what are we going to do to both sides first?
Strip 2 pi.
Okay, right now 2 pi is being multiplied. So how are we going to get rid of it?
Divide.
And if I divide it on the right, I have to
That was very.
divide it on the left.
We're just in
Okay.
it.
On the right side, that's pretty straightforward. The 2 pi in the numerator and the denominator are going to cancel out. It's going to leave us with r cubed. Now on the left side, I'm going to keep it as exact as possible. I'm only going to divide by 2 at this point. So what's 1,000 divided by 2?
500.
So we have 500, and it's still over pi.
Why would we do that?
Just to keep it as exact
simple
as
as
possible.
Because that's what the Greeks
Okay?
That is
Now how do I find out what just 1 r is?
Minus.
Yeah, cube. I can't get cube rooted.
Cube root.
Yeah.
Okay? So translation here, guys. R cubed is r times r times r. And I just want to figure out what 1 r is worth. So I need to find the cube root of this thing, which means I do the root symbol with a 3 on top of the little nose here. And I have to do the exact same thing to the other side.
37.84.
On the, so I think you might have square rooted. You need to
So
cube
wait,
root.
Yeah.
Okay?
How do you do
On
that?
the right side, it's just leaving me with r. And on the left side, I need to take the cube root of 500 and
So
divide
500
it.
divided by pi and then cube root the 5.
You could do that too. You could do 500 divided by pi and then cube root the answer.
I'll do that.
Okay? So go ahead and try that.
What's simpler?
You should get 5.42. If you didn't get that, go ahead and try again. If you haven't tried yet, try now.
Isn't it like a?
I got 2.52.
No, you're doing it.
Maybe your calculator's just.
Jen, let me try.
Okay,
What button do you click?
if the radius is this, how do I find out the height of this can?
Times by 2.
Yeah, height is 2r. So we've got 2 times 5.42, which is 10.84.
God. It's math.
What?
God.
Yes.
God.
So,
The Greeks.
the
not gonna put any centimeters there or anything?
radius,
Nope.
you don't necessarily need to because I'm going to write a final answer in my sentence. But typically, yes, you would. The radius is 5.42 centimeters. And the height is 10.84 centimeters. Now, what we actually needed to do is not just find the dimensions. What does the question say? It's, well, in A, we're still in A. It says determine the least amount of aluminum required to construct the can. So we don't need to say, oh, the final answer, the radius of the can is this and the height is that. It's not asking that. It's saying, exactly, it's saying what amount of aluminum did you need to use? What is the surface area of the can? So I'm going to, because I'm almost out of space, just run over here. Surface area of a can, of a cylinder, is, you'd have to look at your sheet for the formula. It's 2 pi r squared plus 2 pi r h. To rerun through this, guys, pi r squared is the area of a base, and on a can you have 2 bases. And this part, 2 pi r, is the circumference of a base times the height. That will give you the rectangular wraparound part.
Genius.
Okay? It's not the first time you've heard that.
Nope.
Here we go. 2 pi, and the radius is 5.42, and we're going to square that. And then separately we're going to add 2 times pi times r, which is 5.42. 2 times h, which is 10.84. Now, if you're real quick, you could actually look at this and say, oh, that's actually, because h is 2r, this is actually 3r. You don't need to know that, but it would be just 6 pi r would get us the exact same answer as this.
So we're done.
So, plug those things in your calculator. Cubs, try it in your calculator. Ronnie, try it in your calculator.
I don't know my calculator works, to be honest.
I'm not sure how that's stopping you at this point, 30 minutes into class. Saying you don't know where a single extra calculator is in the whole room.
Hey, Mr. Reed, can I
Okay.
550.
You've also been sitting around wasting your time.
I borrowed Jaden's.
I was about to say that. Thank you very much.
Alright, you should have gotten that the surface area of this cylinder is 554
I got 541. Did you get
500
centimeters squared.
552.5?
Whoa.
Guys, look at what Mr. Reed wrote. That's the answer.
Yeah, that's what I got.
Seriously.
Yeah, I know.
0.7.
553.7 rounded 550.
Okay, folks, let's stop this chit chat and head to B. B says, B says, think about what you did. Describe any assumptions that you made.
No.
Why not? Why wouldn't they use it?
They wanted to minimize it, and this was the best possible answer you could get.
Yeah,
Maybe it's the best possible, but maybe it doesn't actually make sense.
Maybe it doesn't make their need what their need.
Maybe it's not as aesthetically pleasing as a
Wait,
different shaped can.
that equal?
Okay, some assumptions that you can make.
700.
They didn't take into account the aluminum that is at like the seams, where you have to like kind of crimp it together. Those kinds of things. Okay. There's a rim. Those kinds of things. Okay, those are your assumptions. I'm going to delete that part.